it's me, it's Miss Checka. I'm excited to see you. And I'm about to post a link here in the chat box, just in case you didn't see it. Hold on. Okay. I think that's it. Let's see. Yeah. Okay, so it's Monday, y'all. I hope y'all had a very wild and exciting weekend. Maybe you went outside your house. I don't know. Maybe you took like an extra nap. I pretty much like napped the whole time. But I thought I would make Monday be more exciting. So I put on an actual dress and lipstick. So that's how I know it is Monday and not just any other day. And also because I have work. Also, I thought that we would do something a little bit different today for the Nerd Hangout, which is just to read the newspaper together. So in real life, I love to read books. You know this. I love to read books, but I also am a huge reader of newspapers, and I always have been my whole life. And pretty much my favorite section in a newspaper is the science section, because you find all kinds of like weird and fun articles there. You guys already know I really like history. I really like NASA. But I also like just these science sections. And when I was a kid, when I was growing up, when you said like read the newspaper, it really was like a newspaper printed on newsprint, and I'm making this motion because it was on paper. But now, oh, you've got a shark encyclopedia. Excellent, Tess. Well, now reading the newspaper is reading something online. So they often have videos in them, which I love. So I saw this science article in the New York Times, and the New York Times is such a good, it has a really great science section in their newspaper. So we're going to read it out loud together, partially because it is just like a cool article, and partially because it has a really good vocabulary in it and all kinds of like interesting facts. So number one, I put that link there so that you can see it. And so that afterwards you can like maybe see that video. I haven't even seen the video on there. But so you can also see this picture of this fish. So this is the article. Look at this fish. He's so special. I'm going to show him again. Look at him. First of all, he just has this like very goofy expression that he's looking at us with. He's kind of like, second of all, he's really yellow. He has a lot of spots on him. And then the thing that is relevant to this article is that he is shaped like a cube. He is shaped like a cube. So fish come in all kinds of different shapes, but we usually think of them as kind of a round animal. Okay. And Tess, hold on to your shark encyclopedia, because I might ask you for some shark facts. Okay, so this article says, well, first, actually, let's just talk about newspaper articles. So number one, we know which section in the newspaper this is in. It's in the science section. Number two, it has a little subheading underneath it that says trilobites. So it's like a tag, but, you know, on paper. So trilobites, and then it has a big headline and then a subheadline. So the big headline, it says how the world's squarish fish gets around, and then the subheader says the yellow boxfish is more agile than it looks. So listen, when you're reading news articles, sometimes you want to just like skip right to where the story is, but I encourage you to always read the headlines and the subheadings, because it gives you good information about what you're reading. And also sometimes they put jokes in the headlines. So in this case, there's like a dad joke here. It's like a real corny joke because the fish is square, like a shape. But also if you call a person square, you mean that they are like not very fun because they follow all the rules. I, for instance, am a square. Okay, and then it tells us, it's got a picture on it. We've already discussed this picture. It has a little caption under the picture, juvenile boxfish in waters off Indonesia. And again, always read the captions because they tell you really important information. So in this case, we already have a hint about the fish's habitat, Indonesia. And that this is not even like a grown-up fish, this is a juvenile fish. And then it tells us the author, that's the byline, and then it tells us the date. So this is by Cara Giamio, I don't know how to pronounce it, and she published it April 15th, last week. It says, the yellow boxfish doesn't look nimble. Squat and rectangular, it resembles a plastic storage bin with fins. Even its color suggests clumsiness. Juveniles are hard hat yellow with black spots, as if to say, coming on through. But on a coral reef, you'll find these cuboid creatures darting in and out of tight spaces, snatching shrimp from crevices, and cornering like BMS champs. That's my phone, y'all, and I'm sitting on it. The combination of their body plan and swimming style really boggles the mind, says Pim Boot, or possibly Boute. Boute. I don't know how to pronounce it. A doctoral candidate at Wageningen University in the Netherlands. I can already tell this article is going to challenge my pronunciation abilities. So let's stop for a little minute. There's lots of words in here that are telling us shape, right? So in these first two paragraphs, it says squat. It's kind of a person who is squat is kind of short. It's a rectangular. It says cuboid, so like kind of like a cube. When you have oid at the end of a word, like a suffix, it means kind of like that. So an android, for instance, is kind of like an andro, which is man, like a kind of man, a robot man. But in this case, cuboid does not mean that it's a robot. It just means it's kind of like a cube. Ooh, okay, Tess is coming in with the shark facts. Male sharks can bite female sharks if they want to make, okay, females also have thicker skin. Listen, I hope that I do not get bitten on a shark date. I guess I will never go on a date with a shark. Okay. And then we have this great vocabulary. So it says that it's snatching shrimp from crevices. So a crevice is a crack. So you can picture like Finding Nemo. Tess, I know you think I talk about Disney movies all the time, but doesn't this article make you think of Finding Nemo? And when it says like going like a BMX, is like a BMX bike, right? Okay, it says it has also inspired decades of research into how exactly they managed to move with such agility. So here we have a synonym of an earlier word. So when it says nimble and when it says agile, both of those words mean like fast and flexible, right? So if you do a lot of exercise, you do a lot of yoga, then you might be nimble and be able to like stretch a lot. And if you're agile, we also use both of those words with the words quick, right? Quick and nimble, quick and agile. So it says the latest foray carried out by Mr. Boot, or possibly Boute, and colleagues when he was a master's student at the University of Groningen and published in Royal Society Open Science last week, lays out the role of one understudied element, the fish's tail fin. Most fish, from minnows to sharks, have pliant bodies, which they undulate to move through the water. So undulate, y'all, is this. I'm gonna undulate, right? So if something is pliant, that means it's movable. And if something undulates, that means it moves like wavy. Oh, okay. Fair enough, Tess. All right, so let's be pliant and let's undulate. So a wave can undulate, a fish can undulate. All right. But this kind of fish cannot undulate because its body is not pliant. It says, but a boxfish sport a set of hard bony plates called a carapace. A carapace acts like a suit of armor, protecting them against predators but restricting their flexibility. So if they want to move, they can only use their fins, Mr. Boot said. It also gives them their strange shapes. Other boxfish species look like purses, frisbees, or ottomans. So if you are looking at this article online, you can click on those links. So a couple of things. Picture this. Some animals have their skeletons on the inside, and some animals have their skeletons on the outside, right? So for instance, humans, I don't have my arm bone on the outside. I have my arm bone on the inside, right? And I have all of these joints. So I have this kind of joint. I have this kind of joint. I've got joints in my neck. I don't have joints in my head, right? So in humans, you have some joints that work like a hinge on a door, like your knee is like that, your elbow is like that. Some that move like a ball and socket. So like your elbow, you can move it in a circle. Your hip, you can't see my hip, but I'm moving it in a circle. We have all kinds of different joints in our bodies with our skeleton, but some parts of our skeleton don't really have movable joints. So think about your head, like your brain, right? Your skull, you can't like bend it or move it, anything like that. It's kind of a hard carapace a little bit. And it keeps like your soft brain safe, right? Well, some animals have their skeleton on the outside. So think about like a turtle or a tortoise, right? They've got all the squishy bits on the inside, and they have the hard carapace on the outside, and not very many joints. It's like your skull, right? Like Tess, I'm gonna make another movie reference. Like Iron Man. Iron Man has an exoskeleton. So he's like a human guy, but he wears a suit outside that is like a hard carapace that protects him. So that's what this is telling us about this fish, is that most fish, I mean, if you've ever eaten a fish, you know, it has those little tiny bones on the inside, but this fish has a carapace of bones. And that's why it cannot undulate, and it just moves around like a little box. And the only thing that it can really control and move are his little fins. Sidebar, I once upon a time had a pet fish. His name was Jackie Chan, and he was a fighting fish. And one of his tricks is that I would say, "Wave, Jackie Chan, wave." And then he would go like this. And then he would wave at me, and that was his trick. So, carapace, hard, protective shell. In 2015, a group of researchers, including Mr. Boots or Boote, I don't know how to say it, co-authors, published a study suggesting that these carapaces make the bodies of some boxfish species inherently unstable in the water. Other studies have come to the opposite conclusion, saying that ridges on the carapace actually help with this stability. If that's the case, the fins not only propel and steer the fish, but steady it too, Mr. Boot said. Based on previous studies, as well as his own underwater observations, he figured that the tail fin was quite important for modulating yaw, swerving motions that occur on a horizontal plane. When a car hits black ice and fishtails, for example, it's experiencing yaw. This was my favorite vocabulary word for this article because I never knew this word before. Yaw, Y-A-W, yaw, right? And when it says horizontal planes, remember that the word vertical means up and down. Horizontal means across, like this, right? So if it's saying that yaw is horizontal motion, it's not like this, it's like this, right? So if your car is like spinning out of control, it's not going up and down, it's going side to side. So that's what that little like fish fin is doing. And, you know, we talked a lot about ships last time, but some parts of the ship act a little bit like a fish fin so that the ship can navigate. To test this theory, Mr. Boot and colleagues used three-dimensional plastic models of finless yellow boxfish. Such stand-ins are common in this type of study because it's difficult to do it on a live fish. They placed each model in a tank on a rod that kept it in place and sent water rushing past it as though it were swimming, while a sensor measured the rotational force the fake fish experienced. So they make a model, they put the model in the water, they put a pole on it, and then they're like, swim, big fish, swim. They did this repeatedly, each time changing the angle of the boxfish to the water flow. They then put the models through the same test, but added a tail fin. They tried the fin in both open and closed positions. When a yellow boxtail fans out, it more than doubles in size, and in a series of posture, from sticking straight out to kinked right or left. The researchers found that without a tail fin, the boxfish was at the mercy of the water flow. Had it not been attached to a rod, it would have nudged right or left. But an open tail fin stabilized the fish no matter how the body was angled. A closed tail fin had a subtler effect, counteracting the influence of the oncoming water to varying degrees depending on the fish's position. The force measurements also indicated that when the tail was turned, the fish would turn too. I'm going to skip one little paragraph. It says, it also reinforces the viewpoint that the boxfish's shape is inherently wobbly, which Mr. Boot expected because the fish's body floats around so much. I'm going to skip another little paragraph. And then it says, the boxfish, however, keep doing what they do best, driving scientists to distraction with their unlikely moves. As soon as you watch one treat a reef like an X Games course, it's obvious that they use the tail for steering, Mr. Boot said. But to quantify this, yeah, it was some work. So first of all, there's Jamie. Hi, Jamie. All right, so we learned a lot of vocabulary, and we learned how an article is set up. So I'm going to go real fast through vocabulary. If you are a quick, or if you're a flexible animal, like a person, then you can say you are nimble or that you are agile. You can even use this if you mean that somebody has a very flexible mind. You can say they are agile thinkers, okay? If you move in waves like that, that word is undulate, and we're all gonna undulate. So this is, we're undulating. And the word that means that you are flexible and that you can move like that is pliant, right? So like a piece of paper is pliant. It's the opposite of stiff. Carapace, that was one of my favorite words. That's when you have kind of a bony structure more on the outside instead of like a skeleton in the inside. And we think of X-Men. And yaw, which is such a funny word, but yaw is a movement from side to side. So that's all the things that we learned about the cuboid, like the cube fish, and how he uses his little fin to navigate. All right, Tess, since you've got that shark book, why don't you give us one more shark fact? Let's see here. I'm going to wait a little minute because I really want to know some shark facts from Tess. And meanwhile, while we're waiting for a shark fact, I'm going to show this picture of this cube fish one more time because it really is just such a funny looking fish. Look at him with his little yellow face and his tiny little mouth and his polka dots. And we've learned from this article that he steers with his fins, and especially the back fin. And we also learned that he is in a coral reef. Oh, I think I put, okay. Right? Claire! He is cute. Look at him. Look at him! I might have to go to Indonesia and swim in the reef just to see these little cube fish. And after I finish this video, I'm going to click on all of the links to see. Actually, I'm going to do it right now. Oh my God, they're so weird. Okay, definitely click on the links and then scroll through all of the different kinds of this fish because he comes in so many weird shapes. Claire, he does look blob-like in this picture, but the whole point of the article is that he's mostly like a cube. Okay, I think that I put Tess under too much pressure to try and produce a shark fact right away. So Tess, why don't you find a shark fact and then you can tell us the very, very first thing in tomorrow's video, because we have run out of time just a little bit. So, great vocabulary, good little science writing today. I hope you guys had a really, really good weekend. And I will see you tomorrow. And tomorrow, Tess, I will start by asking you a shark fact. And if anybody else wants to come up with like a fish fact or a shark fact, or any fact related to this article for tomorrow, here we go. Sometimes you can find shark eggs on the beach. Woo, okay. I mean, if I find eggs on the beach, I am leaving them alone because, you know, I want those little egg babies to grow up and be happy sharks. All right, guys, that was fun. I will see you tomorrow. Bye, guys.